This video is on decomposition reactions. Decomposition, just that word, means to break apart. So we're going to have, in these cases, something that breaks apart. So your general format is you're going to have something that's big enough to break apart to start, and then it's going to turn into the pieces it breaks into. So if I have AX, for example, so a compound of just elements combined, it's going to be my only reactant. So on the product side, it's going to split into the parts. So another way to think of this is it's the opposite of synthesis. Synthesis was when we had A and X combining to make AX. Now we're just flipping it around. So some directions, it says determine the cation and the anion in the reactant, because that's how you're going to know how to separate it. The products are those separated. Don't forget diatomic elements. So remember those 7. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So if you have those by themselves, you're going to write them always with 2 atoms. So let's do some examples. So I've got H2O here. So I'm going to draw my yield arrow. And the cation and the anion, I have hydrogen and oxygen. Okay, so it splits like that. So hydrogen is going to be by itself. And hydrogen, is it one of the diatomics? Yep. So I write H2. And then I look at the other half, the oxygen. Is that diatomic? Yes. So I'm going to write plus O2. What's left for me to do is just to balance this. So going through, the H's are balanced, the O's are not. So if I have 2 O's on the product side, I need 2 O's on the reactant side, so I put a 2 in front of the H2O, which also affects my hydrogen, so I'm going to put a 2 in front of the H2 on the product side. Okay, let's try another one. CaO. I only have 2 things. Easy to split, right? So I'm going to have calcium separated from oxygen, so I write Ca. Is calcium one of the diatomics? Nope, it's not up there on my list. Oxygen is one of the diatomics, so O2. So now I'm going to go back and balance. So let's see, calciums are good, oxygens are not, so if I have O2 on the product side, I need a 2, oops, there we go, 2 in front of the CaO on the reactant side, which affects calcium, so I put a 2 in front of the Ca. Alright, let's try one more. So the next one, 2 elements, or actually 2 more, sorry. I've got KCl, so I'm going to split it into K. Look, is it diatomic? Nope, not on my list. Plus Cl, is that diatomic? Yes. So I'm going to go balance, oops, Cl2. So my chlorines don't match up. 2 on the product side, so I'm going to put a 2 in front of the reactant side, which then I also need to put a 2 in front of the K. Okay, now we'll just do one more. So H2S, all right, I'm going to separate hydrogen from sulfur. Hydrogen is diatomic. Now, know what I'm saying it's diatomic? It is the 2 on the product side over here is not because this is a 2. Notice, like right up above, I had the 2 here for chlorine. I didn't have a 2 to start. So the subscripts do not carry over. The subscripts are due to charges or diatomic elements. Plus sulfur in this case, which is not diatomic, right? Not on our list. Okay, and then balancing it, it's already done. So those are decomposition reactions.